Hello, everyone. This is the video for the notes in chapter 10.3, polygons, perimeters, and tessellations. What are we going to be learning? Name certain polygons according to the number of sides. We got that. Recognize the characteristics of certain quadrilaterals, solve problems involving polygon perimeters, find the sum of the measure of a polygon's angles, and understand tessellations and their angle requirements. I'm not going to do part 5 because I don't think I'll take a look at the test and see if it's on there, but I don't want to overdo your brain with all of the different stuff we're learning. So let's leave that off for now. Look at this pretty picture of somebody's plot of land. What does it want us to talk about? The plot is an example of a polygon. A polygon, this is an important piece that we're going to know. Any closed shape in the plane formed by 3 or more line segments that intersect only at their endpoints is a, is a polygon. Okay, we know a 3-sided polygon is called a triangle. A 4-sided polygon is called a, say it with me, quadrilateral. Where did it go? Well, it's a quadrilateral. Trust me on that. Here we go. So triangle, 3 sides, quadrilateral, 4 sides, pentagon, 5 sides. So these pictures that they're showing us here, hexagon, 6 sides, heptagon, 7 sides, octagon, 8 sides. The pictures that they're showing us here are called regular polygons, which is what they would look like if every side was the same exact measure. They don't have to look like that, but that's just what they're going to show us for those basic pictures. But then quadrilaterals, we get into a bunch of different types of quadrilaterals. Remember, we used to have that polygon bucket in 10th grade, you guys? So a parallelogram is where both pairs of opposite sides are parallel and have the same measure. So technically a square and a rectangle are parallelograms, even though you tend to think of them as being more not having 90-degree angles and being more kind of slanted like this. A rhombus is the same thing. A rhombus is a parallelogram, but it's a special type where all of the sides are the same. Okay. A square is also a rhombus, but it just has 90-degree angles. A square is a parallelogram. A square is also a rectangle. And then you have your rectangle, which has 4 right angles. You have a square, 4 right angles, all the sides the same thing. Do you see how they're the same as the parallelograms, except they have 90-degree angles? And a trapezoid is a quadrilateral with only 1 pair of parallel sides. Okay, here, the top and the bottom. I guess it could be sideways, but finding the perimeter of a polygon is just as easy as adding up the sums, it is the sum, is summing the lengths of its side, adding up all of the sides. It's measured in linear units. Remember, we just talked about that in our last class. They show you an example. If you didn't know any numbers and you were just talking about the L's and the W's, if you added all those up, the perimeter would be L plus W plus L plus W, or 2 L's plus 2 W, and that gives you the formula. So application of perimeter, let's take a look. The rectangular field we discussed at the beginning of the section, I bet we'll use this figure 10.31, yep, has a length of 42 yards and a width of 28 yards. So those are 2 numbers. And length and width in our formulas, it doesn't matter which one you use, but generally speaking, when they say length, they mean the longer side. And when you say width, you mean the shorter side. Find the if the fencing costs $5.25 per foot, find the cost to enclose the field with fencing. So first of all, you would just find the perimeter, which is adding up 42 plus 42 plus 28 plus 28 and you get 140, hopefully. Let's see, 84. Yeah, I'm just going to assume that that's right because that's what they got here. They just did it 2L plus 2W. Because, oh, I see. See, this is why we went through all of that changing of units from one to the other, is because what it's giving us is yards, but the price is per foot. So what I know is I have 140 yards, right? But I know that the fence costs $5.25 per foot. So the first thing they're doing is they are going to change the amount of yards I have to feet. So I'm going to multiply 140 times 3. And this is what they're doing right here, which is 420 feet. And then you need to multiply that by 525 because that's how much it costs per foot. And your total is $2,205. That's expensive. And that's probably not even including having people come out and install it for you. Just saying. All right, your first checkpoint here, a regular field has a length of 50 yards and a width of 30 yards. If fencing costs $6.50 per foot, find the cost to enclose the field. So the first thing you're going to need to do is find the perimeter in yards. Convert that to feet. And then multiply by price, by cost. Okay. This next part, the sum of the measures of a polygon's angles. We've done this before in the fact that we know that a triangle adds up to be 360, or blah, blah, blah. A triangle adds up to be 180 degrees, right? This should just be something we remember. I mean, you don't have to, I'm not saying you have to remember it, but you probably do remember that a triangle adds up to be 180 degrees. A four-sided figure, so look, this is how it's telling you, a four-sided figure, it put these two triangles together. So it's saying the measure of two triangles would be 360 degrees. I also tend to think of just your regular polygons, your basic polygons. That's how I remember. If I'm looking at a rectangle, right, and it has four, I know it has 490-degree angles as an example. And all of the quadrilaterals are going to be the same. I know that 90 plus 90 plus 90 plus 90, just like this, 90 plus 90 plus 90 plus 90 is an entire circle, which is 360 degrees. A five-sided figure is, I think it's funny how they're doing this as triangles, which I get is going to lead us into tessellations. The way I always think of it is kind of our circles. So here we have broken out our circle into four pieces, right? And it adds up to be 360 degrees. Here they've put three triangles. Oh, because it leads us into the formula. Okay. So the three triangles, which would be 3 times 180, is 540 degrees. So anything with 5 sides is 540 degrees. And 6 sides would be 4 triangles. They're just adding another triangle. And so a 6-sided figure is 720. So they're just taking that triangle and multiplying it by how many, the original triangle by how many that they use to draw that. So we have 1, 2, 3, 4, 5, 6, which makes us a hexagon over here. So this is kind of like when we used to be finding those patterns, like how much are we adding on each time? What this does is it boils down to the formula the number of sides minus 2 times 180. So just make sure you know this formula and you can figure out the amount of the sum of all of the angles, no matter how many sides that there are. All right, que próximo. Using the formula for the angles of a polygon, find the sum and the measure of angles of an octagon. So an octagon, our number of sides is going to be 8. So if we put that into our formula, we have 8 minus 2 times 180 equals 1080 degrees. Okay. So in a regular octagon, if you divide that by 8, in a regular octagon, all of the angles are going to be the same. So if you take that 1080 and divide it by 8, you know that each angle is 135 degrees. So each angle in an octagon is an obtuse angle, well, in a regular octagon. Okay. And then it says, oh, so we just did that. We found the measure of A was 135. Is that what I got? Why am I not remembering correctly? Yes. And then the measure of angle B is supplementary, which means A plus B is going to add up to be 180. And if A is 135, then B must be 45 degrees. Okay. So in your checkpoint 2, find the sum of the measures of the angles of a 12-sided polygon. N is going to be 12. So your formula will be 12, sorry guys, minus 2 times 180. And then if you divide that answer by the number of sides, 12, or the number of angles on the inside, 12, you'll get the measure of each angle, which is part B. All right, and we've gotten to the part about tessellations, which I'm not going to make you do right now, but if you're interested, it's pretty cool. Go ahead and read through if you're interested in art or patterns, and let me know if you have any questions.